Hey, what's up guys? Today we're going to be doing problem number 1575, count all possible routes. Before I begin, I just want to mention I do LeetCode videos, LeetCode solutions. I do book reviews, tech videos on my YouTube channel, so please check that out. Please leave a like and subscribe if you can. Thank you. So we have to count all possible routes. You were given an array of distinct positive integers, locations, where locations I represents the position of city I. You're also given integer start, finish, and fuel representing the starting city, ending city, and the initial amount of fuel you have, respectively. At each step, if you're a city I, you can pick any city j such that j does not equal I, and j is within locations, and move to city j. Moving city I to j reduces the amount of fuel you have by basically the difference between the two locations. Please notice that absolute blah blah blah. Notice that fuel cannot become negative at any point in time and that you're allowed to visit any city more than once, including start and finish. Return the count of all possible routes from start to finish. Since the answer may be too large, return a modulo. Okay, and so we have our locations array 2, 3, 6, 8, 4. The start. These are the indices. Okay, so we're starting at index 1 and we want to finish at index 3. Okay, so city 3 and we want to index at location 5. So the first, we have to return all the possible routes. So the first route is, let's say we started at 3 and we jump directly to 8. Okay, how much fuel is that going to take? 5, because the difference between 8 and 3 is 5. Or we could go from 1 to 2 and then to 3. So from 3 to 6, which is 3, and from 6 to 8, which is another 2, so that's 5. Again, another example, 1, 4, 3, and then 1, 4, 2, 3. You can kind of just work through it yourselves. I'm assuming if you already got here by now, you obviously already worked through some of the problems, examples yourself. Okay, now let's think. How are we going to approach this problem? My goal in these kinds of videos is to teach you how to gain intuition into approaching the problem. Well, first thing we have is now this. We know that we're jumping from one city to another. And we know we can jump from one city to any other city. We can keep on going. And what we don't know is we don't know how many jumps it's going to take us from our start to our finish, right? So we need to figure that out. And there could be also a variable number of jumps, right? That's why we're returning the output, and that's why there's different answers. And the different solutions we can get. We can jump from this city to that city, or that city to this city, anyway, right? So now we know that because we're jumping from one city to the next, and it can happen a huge possible number of ways, a large number of different ways, then we know our answer, we need to approach the answer recursively. So we know we need to have a recursive answer. We need to have a recursive solution. So that's point number 1, okay? And how did we get to that already? Well, we know we're jumping from city to city and we can keep going and we don't know how many times. So we know we need to do it recursively. Okay. Now, what's happening at every jump? That's the next thing you need to think about. Well, at every jump, it costs some fuel, right? So at every jump, we use up some fuel, okay? At every jump, we use up some of our starting fuel. Okay, great. What's the next thing? Well, let's think about it. Now, how do we know we have a possible solution? Well, we're going from start to finish, okay? So at some point, where we're at currently in the recursive call might be our finish. So basically, if we reach the finish, then we know we have a possible solution. So how do we know we reach the finish? Well, in that recursive call, if our start is equal to our finish, then we know we have a possible solution. If our start is equal to finish, we know we have a possible solution. Okay, great. What's the next thing? Well, when our start is equal to finish, we know we have a possible solution. Okay, now keep in mind to number 2. At every jump, we use up some fuel. Well, when can we no longer jump? When can we stop jumping? What is our base case? When do we have to stop going in recursively? Well, when can we no longer keep traveling from city to city? When we run out of fuel. And how do we know we ran out of fuel? Well, when our fuel is negative. We're not going to check if our fuel is 0 because we need to also keep in mind our start to finish. So if our start is equal to finish and our fuel is 0, that's okay, right? So only when our fuel is negative, we stop. So that's basically it. That's the whole entire answer. And from there, once you get these 4 points down, the rest of the answer becomes like cake. It's clockwork. So now let's just keep in mind some of the restrictions they pose on us. Okay. Number 1 is if you try to code a solution just from this alone, you're gonna reach a TLE, time limit exceeded. Why? Well, because keep in mind now, our finish is always going to be the same. Our possible next locations are always going to be the same. What changes at every step, at every recursive call? Well, the start, where we're starting at, because at each recursive call we start at a new position, and our fuel, our leftover fuel, because every time we jump, our fuel changes. So these two variables are the ones that are going to change at every time. So our start and fuel are always changing. Now, one thing to keep in mind is because our start and fuel keeps changing, that's why we have different answers. At some point in the recursive calls, you might have already started at this position with this amount of fuel. I might have already started at position 3 with, let's say, 15 fuel left. Or I might already have been at position 8 with 5 fuel left. Okay? And I might have already computed the number of possible solutions at position 8 with fuel 5 left. So I need to keep track of that. I need to save my answers. I need to memorize the solution. So every time I calculate solution, save it based on start and fuel. Okay? I have to save it based on the start. So for this start and this fuel, do I have a solution already? Yes, then use it. If I don't, we'll figure out the solution and then save it for this start and fuel. So then next time, if I ever get to this point again, right, then I know the answer from here. I can just grab it because I already saved it. That's one thing. That's how we're going to optimize it. Now the next thing is, well, now how are we going to handle this? We'll return a modulo 10 to the 9 plus 7. You'll just see that. You'll just, every time you return an answer, or every time you increment the count, you want to modulate it by this number, so it always stays under this range. So that's that, and I'll show you the solution in 1 second. Okay, so this is the solution. Let's just walk through it. So we have our module. We're keeping this variable intact right there. And then we go in. I create this memoization double matrix. And as you can see, it's based on our start position. So because how many different start positions can we have? Well, it's based on the length of our location. So I do locations +1. The reason it's +1 because indices start at 0, as we always know. I don't want to subtract 1 at each time we're checking it, so I increase the size by 1. So that's that, and then we have the fuel. Remember, that also can change. It can go from 0 all the way up to the amount of fuel we have. So that's why the length of this is fuel. I fill everything up with -1. Then I call it, and I start my recursive calls. So once again, my count is 0. I start at 0. That's the first thing we keep in mind. Okay. Then remember what we said. Well, every time if our fuel is less than 0, this is actually part of the older. This is the second time I'm recording this. Made some mistakes in the first one, but anyways, it wasn't mistakes, but it was a bad explanation. So if the fuel is less than 0, then we stop. So if the fuel is less than 0, then I just return the count, and that's that. The next thing is, well, what if I already calculated this answer before? So if I already calculated this answer before, meaning if memo at start and at this start and at this fuel is not -1, because if it's a -1, it means we haven't calculated before, then that whatever. What am I saying? Anyways, so if it's not -1, it means we've calculated before and we just return what we've already calculated. Next, if our start is equal to finish, that means we have a possible solution, so I'll increment the count. What's next? Then I go through all my other possible locations. Okay, I don't want to travel back to myself when I'm traveling to my other locations. So when my I is equal to my start, I'll skip past it, because this step means that when this means skip the city I'm currently at, because I don't want to just travel right back to myself again and again and again. So if that's that, I just skip it. Then I calculate the fuel loss. Remember, it's this location I minus location J, which is just this, where I'm starting at to where I'm traveling to. The I here is a little confusing, but anyways, whatever. So then I get the absolute value of that, which I'm just calculating the difference between the two cities, and then I call my count routes again. I have a new starting point, same finish point, same locations. I have a new fuel once again because I lost some fuel now. So I do my fuel minus the amount of fuel I lost, and say memo. And whatever answer I return from that, I increment it back to my count, and then I mod my count just to make sure it stays under this number. And then I keep doing that for all the possible cities, and you'll see that you just keep jumping recursively. So you jump from one city to the next, to the next, to the next. Every time you run out of fuel, you just stop. Every time you start is equal to finish, you increment count, and you'll just keep returning upwards. And eventually you come back up to this top call. And then this will finish, and then I want to save the call that I'm at. Or I want to save the calculation, the possible ways for this start and for this fuel. So maybe another recursive call will use it. and then I just return the final count. And that's basically the answer. I hope you guys enjoyed. Please don't forget to subscribe, like, comment. Let me know if I can improve. Let me know if you have any questions or anything. Just leave in the comments below.